A very good morning to all of you and welcome to the second day of ICTA 2018. So this is the last day of the conference, but of course it is followed by workshops and the cultural tour. So today is going to be a very long day, and before we just kickstart, let me brief the proceedings of the day. So first we have the keynote number 3 by Professor Paolo Trunfio. And then we have 3 parallel sessions like yesterday. The first session is right here in the Professor V.K. Samaranayake Auditorium on social media. And session 4B about statistics and computing, that will be there at the ADMTC seminar room. And session 4C on artificial intelligence and cloud computing in the mini auditorium. After that, we break for tea and gather here once more at the Professor V.K. Samaranayake Auditorium right here for Keynote 4 by Professor Christian Ronner. And then, once again, we have 3 parallel sessions. Session A, which is right here, is on IoT and virtual reality, and session 5B on networking and sensor networks at the ADMTC seminar room. And then we have session 5C on social media at the mini auditorium. So after the sessions, we break for lunch, hopefully around 1:40 p.m. And we have our lunch hour. And once again, we have the session starting at 2:40 p.m. Session 6A on data mining right here. Session 6B on bioinformatics and health informatics at the ADMTC seminar room. And we have session 6C on robotics. And after the sessions, at 3:45, once again, we all meet at the V.K. Samaranayake Auditorium right here for keynote number 5 by Dr. Kazundi Soiza. And then we have the closing ceremony followed by the tea break. So let me now introduce the keynote speaker in the morning, Professor Paolo Trunfio. Professor Trunfio is an associate professor of computer engineering at DIMES, or DIMES, Department of the University of Calabria. He's also the co-founder and managing director of D2K Lab, an academic spin-off of the University of Calabria. He's currently serving as associate editor of IEEE transactions on cloud computing, and is also a member of the editorial board of several scientific journals, including Future Generation Computer Systems, Peer-to-Peer Networking and Applications, and the Journal of Big Data. So the keynote title is Social Media Analysis for Trajectory Discovery in Large-Scale Events. I repeat, Social Media Analysis for Trajectory Discovery in Large-Scale Events. Professor Paolo Trunfio, over to you, sir.
So, good morning, and thank you for your kind introduction. So this talk will be on the use of social media analysis for understanding the behavior of people, in particular for discovering the most frequent trajectories people have when attend large-scale events. So social media analysis is a relatively recent research area whose aim is the study and implementation of techniques, software tools, and applications for collecting data from online social media analysis, platforms like Facebook, Twitter, and so on, and for analyzing this data using data mining and data analytics techniques and tools. The general goal of social media analysis is to extract information and knowledge which is not explicit in data, and the use of this knowledge to make choices which are vital for the particular application. Social media analysis is a rising research topic. If you look at this histogram, you can see that in the last 7 years, the number of publications containing the word social media analysis or social media analytics has grown by a factor 10. So, of course, this is just a trend because, there are publications which do not include these words, but they are talking about social media analysis too. So, online social media are characterized by both huge numbers of users and huge volumes of data. According to some statistics, today we have about 2.5 billion users of social media. And some projections show that we should have about 3 billion users in the next 3 years. Of course, this huge number of users also produce huge volumes of data. Just a couple of examples. Every minute, the users of Instagrams publish 50,000 photos, and the Twitter users post about 500,000 tweets per minute. In many cases, these social media items are also geo-tagged, which means that they incorporate some information about the place from where these items were published. Typically, we have the coordinates, latitude and longitude. In some other cases, we have other informations like location tags or the name of the place, which allows to know the user's position. When users move from a set of places, we have a lot of information about their behavior. And in fact, there is a growing interest in the extraction of mobility patterns, exploiting this information from large volumes of social media data. We worked in this direction by proposing a methodology which is called SMA-40D, which stands for Social Media Analysis for Trajectory Discovery, which is a basic methodology composed by a few steps for basically obtaining 4 goals. The first goal is to use social media data to discover the most visited places and the most attended events. If you have a sufficient large number of people who attend a given set of events, you also have the possibility to extract with a good accuracy information about which are, of course, the most visited places by these people. The second goal is to discover the most frequent sets of on visited places. So the goal here is to see if someone has visited a place, which other place it's likely he will also visit. So it's an associative analysis. The third goal is to discover the most frequent mobility patterns, so to, in some way, understand which are the paths followed by people when they attend a set of events. And finally, we are also interested with this methodology to understand which is the origin and the destination of people. So understanding, for example, from which country or city or region people attending a large-scale events are coming, or where people go for touristic reasons after they attend, for example, a conference. This is very important in particular when you want to understand the touristic potential of an event, for example, of a conference. I will show the methodology using first an abstract use case, and then I will go into the details of two use cases that were really made using our methodology. The first was the analysis of geotagged tweets sent by Twitter users during the Soccer World Cup in 2014, which was held in Brazil. And the second one is the analysis of the geotagged posts published by the Instagram users who attended Expo 2015, which was the Universal Exposition held in Milan, Italy in 2015. So this is the outline of the remainder of the presentation. I will introduce some definitions, then the methodology driven by a running example, the two case studies, and finally some conclusions. So let's start with some definitions. We have basically, as a starting point, a set of places of interest, where each place of interest is a specific geographic area which is of interest for a community during a given time period. For example, a place of interest may be a business location, for example, a shopping mall, a touristic attraction, a theater, a museum, and so on, or some other location like a square, a street, a pavilion, which is in some way relevant to an event. We should consider that a place of interest is not limited to a single geographical point, but in general it refers to an area. For this reason, we can also use the term region of interest to refer to a place of interest, because it's a region and not simply a point or a line. The second set, which is defined in order to introduce our methodology, is a set of events. Events which involve a large presence of people. Each event is characterized basically by two informations. The first one is the place where the event is held. And the second information is the temporal range, so the time when the event starts and the time when the event completes. Many examples may be made about events, just a few examples. For example, a match played in a stadium, a showcase hosted in a pavilion, a concert held in a square. Beyond the basic information described before, we can also have some additional information about an event. This all, of course, depends on the specific domain. Finally, we have two sets. We have G, which is basically the input data, a set of geotagged items which are basically in some way extracted from a social media platform. Each item is a social media content, like, for example, a tweet, a post, a photo, or a video, which was posted by a user during a given event from a given place. A few information are included in a geotagged item. Typically, we have the user ID, which contains the identifier of the user who posted the social media item. We have coordinates, latitude and longitude, a timestamp, which indicates the time when the item was posted, some text, and some text. Finally, we have a set U, which is the set of users we are observing. Each user is a user who has published at least one post in G. So basically, we derive U from G. Well, the methodology is composed by 7 steps. First of all, we start by defining the set of events. Then we define the places of interest, P, where these events are being held. Then we have the third step, where we collect and preprocess the geotagged items, G, which are related to the events in E. The fourth step is the identification of the users who published at least one of the geotagged items in G. Then we create an input data set, D, which is typically a transaction data set used to be given in input to data mining or more data mining algorithms, which is made at step 6. And finally, we have results visualization. In order to show how each single step works, I'm going to use a running example. Let's imagine we have a large-scale cultural event in the center of Rome, which is composed by free or paid events like concerts, guided tours, outdoor exhibits, spread over 3 days. So step 1 was the definition of the events. So this step is aimed at defining the events which are being observed by our analysis. Here you can see an example. There are 5 events. The first one is held at Colosseum, which is a famous place in Rome. You can see we have the starting date, the ending date, and some optional data. In this case, we have 2 optional data. Information about the fact that the event is paid or free, and the type of event. In this case was a paid concert in the Colosseum. And so on, you have other events. Then you pass to the definition of the places of interest. Basically, here you have to identify the boundaries of the places where the events are held. Here you see a map where there are 5 places, the Colosseum, Roman Forum, Tiber Island, Circus Maximus, and Piazza Venezia. In order to derive these places, you have basically 2 possibilities. The first one is that you take the map and you identify manually the boundaries, for example, some polygons. But there are also other possibilities to derive automatically the boundaries. For example, you may use OpenStreetMap, which is a service on the web. You can pass the name of a place, and OpenStreetMap returns to you the boundaries automatically. But there are other possibilities depending on the country. For example, you may use cadastral maps, which in some cases are available as web services. Step 3 is often the most critical step in the process. You have to collect data from social media platforms. So basically, you have to use the APIs of Twitter or Flickr or Instagram or Facebook, if you can, to collect data about all the available social media items that were posted during the event in the given place. After that, you have to pre-process this data in order to clean data, select which post to keep or not, and to transform data to make it suitable for the subsequent analysis. You see, for example, in the bottom of this slide, social media item, G1, which is characterized by the user, U1, in this case, just an example, latitude and longitude, timestamp, text, and some tags. And this was a social media item posted by the Colosseum, as shown in the figure. Step 4 is the identification of users. You have hopefully large number of tweets or other social media items, and then you just identify the unique users. For example, you see that the user U1 has posted one post from Colosseum, Circus Maximus, Roman Forum, and Piazza Venezia. So there are 4, for example, tweets from this user. So you just keep once U1 in your database, and so on for the others. Then step 5 is the creation of the input dataset. As you probably know, most data mining, trajectory mining algorithms work on transactional datasets. So it's a big table that must be prepared in order to let these algorithms work properly. The input dataset is a set of transactions, T1, T2, and so on, where each transaction is a tuple composed by a set of information. The first information is the user ID, then a set of events, and then some optional fields. Each event in a transaction is an event which was attended by the user. Whereas optional fields are optional descriptive fields, for example, nationality, interests, that may be used to further characterize the user. And so this may be useful for specializing the analysis by targeting some specific group of people. Here you may see in the bottom there are some examples. You see, for example, that user U1 attended event E1, E2, E4, E5. We know he is Italian and likes art, and so on for the others. Step 6 is the step where we apply standard or customized data mining algorithms to extract the trajectories or the attendance rules we are interested in. Basically, there are 2 classes of algorithms that can be used. Associative analysis, or associative pattern mining, and sequential analysis, or sequential pattern mining. With the first type of algorithms, associative analysis, we try to discover the item values that occur together with a high frequency. For example, we want to find the sets of places that are most frequently visited together by users. With sequential analysis, we basically want to discover the sequences of elements that occur most frequently in our data. Differently from associative analysis, in sequential analysis, it's of paramount importance the time dimension, and also the chronological order in which the values appear. For example, in this case, we may want to find the most frequent sequences of attended events. In other terms, we want to find the mobility patterns. Examples of rules that may be inferred by our data are like in this example. These are, of course, aggregate information. An aggregate information may be that 3 users attended events E1 and E5, 3 users attended E2 and E5, and so on. Or 2 users, like in the last row, attended E1, E2, and E5. Last step is results visualization. It's an important step, despite being the last in our list, because sometimes you have very complex data, not like in the example before. You have a lot of information about patterns, and it's critical how to present these results to the final users who are not necessarily experts of data mining or statistics and so on. We think there are three main guidelines should be followed to prepare a visualization of your data. First of all, preparing a visual representation of quantitative information. The second is to, of course, minimizing the cognitive efforts people must put for decoding the system of science you used. And then trying to structuring your graphic elements into hierarchies. Actually, this means that you have, for example, to follow the rule that if you have a large number of people on a given path, you may represent that path with larger rows and vice versa. So if you have just a few people going from one place to another, you use a very small line for that. Well, now I am going to show you the two case studies we demonstrated using our methodology. The first one is the Soccer World Cup held in Brazil in 2014. As you may know, it's a quadrennial world championship. So every 4 years you have this competition. The edition held in 2014 was attended by 32 national teams, and there were a total of 64 matches played in 12 stadiums spread all over Brazil. It was a very large event with more than 5 million people who attended soccer matches and related events. So, let's start with the definition of events. The events here are very simple. We have 64 matches, so we have 64 events. Each event was characterized by the place, which is a stadium, beginning and ending times. In this case, we considered as a beginning time 3 hours before the match and as an ending time 3 hours after the match. The reason is that we want to get, for example, in this case, tweets from the stadium, and people go to the stadium a lot before in order to take a seat and leave typically 1 hour at least after, because it's a long process to exit. Then we have the first team in the match, the second team, and an additional information which is the phase of the match. So this can have a set of values, opening match or group stage, round of 16, and so on. 2 examples are reported below. E1 was a match between Brazil and Croatia, was the opening match, held in the stadium of São Paulo in a given date. Then another example is E2, the match between Mexico and Cameroon in Natal. Then we pass to the definition of places of interest. Also, this step is very easy in this case because we just have 12 places, 12 stadiums, P1, P2, P12. Basically, the region of interest extracted for a given stadium is the smallest rectangle that fully contains its boundaries. So we just used OpenStreetMap to get this information. 2 examples are below. The first is the São Paulo Stadium, Arena de São Paulo. The second one is the Estádio das Dunas at Natal. Then we used the Twitter APIs to collect about 500,000 geotagged tweets that were posted from the stadiums during the matches. And each of these tweets contains user ID, coordinates, timestamp, text tags. and an indication which is optional about which application was used to generate the tweet. For example, if you use Twitter for Android on a mobile phone, you will find the indication Twitter for Android as an optional field. This is an example. It was a tweet published during Brazil-Croatia. After data collection, you have to, and we had to make some data preprocessing. The goal, data preprocessing is very important. You can't use data as you get if you want to have reliable results. We have to clean data, select data which are reliable, and transform data to make it ready for analysis. Basically, cleaning is made by removing all the tweets with a reliable position. There are cases, for example, in which the coordinates are automatically set by the application. These tweets are discarded because applications are able to set a position even if you are not there. And so in this case, we have to remove this data even if you really were there, but we can't be sure about that. Then selection means removing retweets. So if you tweet and someone else retweets, you have to remove retweets from your body of data. And finally, we had to transform data by keeping just one tweet per user per match. Because in our case, we were interested to know only if a user attended an event. So it was not necessary to keep more than one tweet per user per match. Finally, we have the input dataset, which is a list of matches attended by a single user. So we have a set of transactions, T1, T2, Tn, where n is the number of users. And each transaction is composed by a user ID and a set of matches he or she attended. Having the input dataset, we can make the trajectory mining analysis. Starting from D, basically, we have to find the sequence of geographic regions that emerge as frequently visited in a given temporal order. We have in order to measure the reliability of a trajectory, we use the support measure, where the support of a trajectory pattern P is the number of transactions containing P. Specifically, a frequent pattern FP with support S, indicated as FP, a set of matches with support S, is an ordered sequence of matches Mi, Mj, Mk, where S is the percentage of transactions in D which contain this frequent pattern. Some results. I'm going to show you some results that were published in a newspaper in Italy. Basically, we have the number of people attending the matches over time, the number of matches attended by fans during the competition, the most frequent sequences of matches attended by fans in the same stadiums or to follow a given soccer team, and finally, the most frequent movement patterns. So the first result is a comparison between our numbers, so the numbers of Twitter users who attended the matches, and the official numbers which were given to the press by the organization. So we have 64 matches. Below you have the Twitter attendees, and in upper part of the graph you have the official numbers. Of course, the scales are different because there are more official attendees than Twitter users in a stadium. In some cases, we registered the same data peaks in Twitter and the same data peaks in the official data. This happened for the matches listed before. We also have this figure which shows the same numbers but grouped by phases, where the phases are opening match, group, round of 16, quarterfinals, semifinals, and the final. We have on the left the official attendees, on the right the Twitter attendees. If we look, there is a good similarity. In particular, we have a Pearson correlation number equal to 0.9, which means strong correlation between the two. Of course, you cannot, from Twitter data, derive absolute numbers. You can just derive trends. Then we have some specific results about the number of matches attended. The first, this table shows the number of matches attended by the spectators. We have that about 60% of people attended just one match. 16% two matches, and so on. We have the interesting result that 3.7% attended 5 or more matches. This is quite strange because it's not usual that people can afford buying 5 or more tickets. Actually, we looked into the Twitter profiles of these people and we found that they were journalists, so they were paid to do so, and so their tickets were paid by someone else, of course. The second result is the general classification of the paths followed by fans who attended at least 2 matches. So, if you consider only people who attended 2 or more matches, what they did. This table shows that people who attended exactly 2 matches did so staying in the same stadium in most cases. So 63% of people who attended 2 matches stayed in the same stadium, which also means in the same city. Whereas 22% did so staying in different stadiums but following the same team, and so on. So these results show that most of those who attend multiple matches did it staying in the same city. This is reasonable because when you have to organize your trip, it's not easy to go through many cities. The only significant exception is given by journalists once again. Then we have, as another result, actually there are many results, I am just showing some examples. The most frequent 2 match sets observed during the group stage, so during the first part of the competition. Here, this graph was made by a professional in graphics, not by us. And the idea here is to show the results in this way. There are these these circles in the middle. The larger the circle, the larger is the number of people who attended the specific pair of matches indicated by the flags. For example, you have that there is a significant number of people who attended England, Italy, and USA, Portugal, and also Argentina, Bosnia, Spain, Chile, and so on for the others, with a support which is decreasing proportionally to the size of the circle. Then we have the classical trajectory mining analysis. This is, for example, this figure shows the most frequent paths of fans who attended 2 or 3 matches of the same team during the group stage, so the first part of the competition. The lines represent paths, and the sides of each single line represents the support. So the thicker the line, the larger the number of people on that path. For example, we registered typically large paths from people coming from South America, like from Mexico, of course, Brazil, Colombia, Argentina, and so on. This is, let's say, normal because people from the same continent were able to arrange more easily this kind of movements through Brazil. Okay, these are an explanation. The most frequent two match sets were basically involving people from Colombia, Mexico, Argentina, and so on. Another example is a specific analysis on the fans who attended the opening match, which was Brazil-Croatia. Here we wanted to see what happened to those who went to this match. And the results were that at the end of the group stage, about 50% of these people did not attend other matches, so they just went to the first match. Then there was 13% of people who moved to Rio de Janeiro to attend other matches, while 9.5% attended other matches in the same stadium. So they stayed in the same city. Finally, about this example, we have an aggregate analysis where the goal is studying the movements of fans during the different phases of the competition. To this end, we grouped the matches into the following phases: opening match, group stage, round of 16, quarterfinals, semifinals, and the final. This figure basically shows, you see, there are on the x-axis the phases, opening match, and so on. On the y-axis, we have these circles which represent the support. For example, the first row says that there was a large support, so many people attended one match in the group stage and the round of 16. And this was the most frequent pattern. Then we have, in the second row from the upper part of the figure, that quite a large number of people attended group stage and the quarterfinals, and so on. We have the least frequent pattern, which is people who attended one of the semifinals, or both, and the final. This is, of course, the less frequent also because I imagine that the tickets for these matches are the most expensive. So most frequent is group stage and round of 16, least frequent semifinal and final. Well, I go through another use case which is completely different, in a completely different area, but same methodology. Basically, here we focused on Expo 2015. Expo is a universal exposition, which that year was held under the theme Feeding the Planet, Energy for Life. Basically, it was about green food. It was hosted in Milan from May to October 2015, so it was 6 months long. The exhibitors were countries, international organizations, civil society, and so on, for a total of about 200 exhibition places. It was a very large event with about 22 million people visiting it over the 6 months. Well, in this case, the definition of events means basically that we have 188 events, which are the showcases. And in this case, each showcase starts exactly the May 1st, 2015, and ends the October 31st, 2015. The place where each event is held is a pavilion. So typically a building or a part of a building in case of shared pavilions. The definition of places of interest was made by taking the map of Expo 2015 and identifying, using OpenStreetMap, the boundaries of each pavilion. For example, here you have the Italian pavilion with its boundaries, the American pavilion, and their corresponding region of interest. Data collection. In this case, we use Instagram, not Twitter for our analysis. Because after a brief analysis, we found that Instagram was the most used social media platform inside Expo. This is easily understandable because Instagram, you know, is used to post pictures, and so people went to Expo and used to post pictures from the different pavilions. We not only collected geotagged posts taken during the exhibition, we also collected posts which were post and pre-related. In other terms, when we discovered that a given user was at Expo, we also downloaded his pictures which were posted from 1 month before to 1 month after his or her visit to Expo. This was useful to understand the origin and the destination of that user. Some numbers, we had that about 200,000 Instagram users visited Expo, with about 500,000 posts published during the visits, and 2.63 million posts published by users from 1 month before to 1 month after their visit to Expo. Formally, the set of geotagged items is given by G1, G2, and so on, where each G in this set contains a user ID, coordinates, timestamps, text, and tags. This is an example of geotagged items regarding Sri Lanka posted during the Expo. Sri Lanka had one of the exhibition pavilion, of course, and they had an exhibition about green food in particular, green agriculture, and this was one of the tweets. After collection, G was pre-processed by keeping, as in the other example, just one Instagram post per user, per pavilion, per day. So if a user posted, for example, 3 photos from a given pavilion one day, we just kept one of these because we had enough information by keeping just one. The identification of users was made by identifying among the large number of photos we got the single users, and for each user we got the ID, of course, and the nationality. The nationality was important because at the end I will show you results which are different for the nationality of visitors. In the case of Italian visitors, so visitors from the hosting country, we also recorded the city and region of origin to understand from which region specifically or city people came when attending the exhibition. So in this case, the input data set contains a set of transactions, each one containing a user ID and the set of pavilions a given user had visited. So some results. First of all, the visit trends. So we have here the number of unique Instagram users per day from the 1st of May to the end of October. Clearly, we see that for the first 4 months, the exhibition was visited by a relatively low number of people. and there was a huge growth in the last 2 months. Then we have also some statistics divided by weekday. You see there is a peak on the Saturdays and also quite a number of visitors on the Sundays, whereas the day with the least number of people is Monday. This is reasonable because people work from Monday to Friday typically, and so they tend to go during the weekend, and particularly on the Saturday. Here there is a comparison between the official visitor numbers and the Instagram numbers we got with our data collection. Even if you look, you can find a strong correlation, which is confirmed by the person coefficient, which was 0.7. In other terms, we had, in most cases, that when there was a peak in the official numbers, there was also a peak in the Instagram numbers. Then some statistics about which were the most visited pavilions. The top 5 was composed by China, Japan, UK, Korea, and Russia. In particular, China was visited by 20% of visitors, so 1 out of 5 of all the visitors went to China, to the China pavilion, I mean. And also we have some most frequent sets, so pairs of pavilions visited together. This is the top 5. We have that the most frequent pair was China-Japan. So about 4% of people liked to go to the pavilions of these big countries. Or the second one is China-UK, China-Korea. The fact that China is always in the top 5 is because it's also the most frequent in the previous table. Then we have some statistics about the origin of visitors. This is in particular a figure showing the origin of visitors when the visitors are from abroad, so not from Italy. The largest foreign inflows were from Spain and France. Okay, France is close to Italy. This is one of the reasons. Spain, for the same reason, basically. Then followed by UK and USA. Other significant percentages are Switzerland, which is in the north of Italy, and Germany. Then we made a specific analysis about people coming from the same country. Okay, first of all, I should say this is Italy, and Expo was located in the north, in the Lombardy region. And this shows that most of the visitors coming from Italy were also from the same region of the Expo. So 36% of people were from Lombardy, the same region of Milan. And you see that, in general, most people came from the north, because it's easiest to come from the north to Milan than from the south. And on the right, you find some statistics about the cities. So also in this case, most of the people were from the same city, Milan. This is perhaps the most interesting result we got from our analysis. So, which was the destination of foreign visitors after their visit to Expo. So we wanted to measure the touristic impact of this event to the other places in Italy, because normally people coming from abroad went to the Expo for 1 day, and they stayed in Italy for other, 7 days as a tourist. And the results show that, on the left, in terms of regions of destination, the region where most people stayed was Lombardy, so the same region of Expo, So the most important impact from a touristic viewpoint was in the same region of the event. And then we have also significant percentages of people who went to Veneto. Veneto is the region of Venice. To Tuscany, which is the region of Florence, Lazio, where is Rome, and the others with smaller numbers. On the right, you find a detailed analysis focusing on the cities, not on the regions. And also in this case, you find that 59% of people who was to Expo went to Milan, the same city, followed by Rome, Venice, Florence, and some other cities. So, some conclusions. What is important in our methodology is not methodology itself, but the goal for which we use it. So basically, the idea is that we can use the information extracted using this methodology for future event planning. So if you know how people behaved in a given event, in a given place, or for an event of a given type, we can also use this information for the future. There are many key services which are affected by large events, like transports, security, logistics. And so it is of paramount importance of understanding the behavior of people to organize these services. Our experience about the data we use for our analysis is that even if users send posts at irregular intervals, so there are people who post just once, others who post a lot of images or tweets, but at irregular time intervals. Even so, when we have a very large number of geotagged items, we are able to get accurate analysis. This is confirmed by the comparison between our numbers and the official numbers that were made public by the organizers. Here you can find a publication where there are further insights on the methodology and the results with my co-authors Eugenio Cesario, Fabrizio Marozzo, and Domenico Talia. Okay, I have to give some credits to the Association for Computing Machinery, which supported my visit here together with the organizers of this conference. And thanking you for your attention. If there are questions, I am happy to answer, of course.
So you discarded some tweets that were tagged by the applications.
Yes.
Because you said you cannot be absolutely sure if they got really taken where it says. Did you look at those tweets as well, and did you see parallels, or did you see different behaviors?
First of all, I would better specify what I mean by tweets made by applications. There are cases like, for example, Foursquare that you can use to, in some way, refer tweets to a place. In this case, when you say, I am in this place, Foursquare generates a given very specific couple of coordinates. So we basically found that there were, for example, 1,000 tweets exactly from the same place. This is unlikely to happen because if you have your mobile phone with GPS on and you have two people, even at 10 meters of distance, you have several differences in the coordinates. So this is to say that we removed those because it could be possible that they were actually in another place and the coordinates were put there in an artificial way. So at the end, we, in some cases, had a look to those tweets to see if they were there or not. And in many cases, they were not there. For example, the case is a person in Europe looking at a given match That person tweeted about that match, looking at his TV or her TV on the sofa. But when tweeting, he set as position the position of the stadium. But that position was automatically generated with a given coordinate which is equal for everyone indicating that position. So we were able to check that actually when the coordinate was artificially put, it was for people that were not there, actually. I hope this answers your question. Okay, thank you. There was a question over there.
Rather than offline analysis, would streaming analytics help in the organizers looking at possible improvements for their presentations if the situation is of a long time?
I don't know if you understood well. You asked if you can use this information for future organizations, sorry?
No, while say for example, in the expo example,
yeah?
Since it was of duration 3 months or whatever, during the course of the events, the organizers could get information from a streaming analytics point of view rather than offline.
Okay, the analysis was, in both cases, was made using a streaming analysis. In particular, in general, online social media made available two types of APIs, the streaming APIs and the offline APIs. The first one, of course, allows you to download in real time data about a given event. And the offline allows you to go back for a while and download data for a limited amount of time. It depends on the social media platform. In case of Twitter, you can go back. You don't know how long you can go back. It depends on the amount of data you have on a given source. But in general, we used online streaming. So we were able every day to monitor the situation. And this is a good question because it allows me to better tell the importance of this kind of analysis for monitoring an event and for taking decision in real time. For example, I just make an example. If you, after 1 month of this analysis, understand that most people coming to Expo tend to go to Lombardy, then to Venice, then to Rome, and so on. You know the percentages. In theory, you can offer to your visitors an option to go in those places with a given tour organization. You can organize tours. We can target people based on their nationality and offer specific guided tours. Another example, if you organize a conference and in many years you monitor their social activity and you discover that in the days before or in the day after, they tend to go to specific places in your country, the year later you can organize a tour taking into account the the preferences that have emerged over the years. This also for organizing transportations and so on. I hope this answers your question.
Can this approach be adaptable to more than one source, say Twitter and Instagram combined together to make the analysis?
So please repeat, combining what?
The data sources.
Combining different sources.
Yeah.
Yes, it is possible. There is just one problem in the combination of sources. Is that the user ID of the same person has different user IDs in different social networks. And we do not know automatically how to combine these IDs. You should go into the details and look at the different profiles and saying, okay, these Instagram users has another ID as a Twitter user, and you can combine them. But it is not an automatic operation that you can make with the tools we have now. And there is another problem that I didn't mention before. It's that there is a different level of access to data from different social media. For example, Twitter is relatively open. Okay, their APIs allows you to get data very easily. Most profiles are open. It's very rare that Twitter profiles are closed. So you can download basically a lot of data. Today, Instagram is closed because it has the same policies of Facebook, for example. So the analysis we made in 2015 is not easy to do now. You can do it, but you have to get pre-authorization by Instagram. You have to say what you are doing. You have to publish an example of what you are doing, and they have to authorize you. So the different levels of authorizations is another problem in combining data from different sources, because you can have a large cover from one source and a small cover from another source. And this can bias your results. Okay, so another question over there.
Yeah, I saw that you captured text from the Twitters, and I think you can do lots of analyzing the text in that. Any plan of doing that one?
Okay, what I presented here is about trajectory discovery. Trajectory discovery is made only by using two information, which are coordinates and location tags in some cases. The text here is not directly used in this analysis, but we have other cases in which the text and also the pictures are very important. For example, you may want to have some kind of sentiment analysis on the text. For example, you go to the Italian pavilion, you know people was there, some person was there, but you want to also understand if you like it or not, that place. In this case, you should analyze the content of the tweet. And the tweet may be, how to say, positive or negative about the place. This is another kind of analysis that is possible, can be made using several tools, particularly on the English language, because there are many tools for that, for example, from the area of natural language processing, but is not the goal of this specific methodology, which is only for trajectory discovery. Okay, thank you. Okay, I suppose we finished the session? Okay.
You can ask if there are any more questions left. Please be kind enough to ask those questions during the tea break. So we live in a stage that social media has become a part and parcel of our lives. Professor Trunfio, thank you very much for that very timely presentation that interests all of us, especially in the ICT and related fields. Now, it is the time for the felicitation of the keynote speaker. So for that, may I cordially invite the co-chair, the program co-chair of ICTA 2018, and who is also a senior lecturer of UCSC, Dr. Noel Fernando. Professor Trunfio, you are also invited. Thank you very much, Dr. Noel Fernando, Professor Trunfio.